Hello, today we're going to learn a powerful technique for solving systems of linear equations. By the end of this video, you will be able to solve a system of two linear equations using the elimination method. A system of linear equations is just a set of two or more linear equations that we want to solve at the same time. The solution is the point where all the lines intersect. For example, consider this system. X plus y equals 5 and x minus y equals 1. We're looking for the single point xy that makes both of these equations true. The method we'll use is called the elimination method. The main idea is to add or subtract the equations in a way that eliminates one of the variables, leaving us with a single equation that's easy to solve. So the goal of the elimination method is to get rid of one variable by adding or subtracting the equations. Let's start with a simple example where one of the variables is already set up for elimination. Consider the system. 2x plus 3y equals 11, and 2x minus 3y equals 5. Our goal is to eliminate one of the variables. Let's look at the y terms. We have a positive 3y in the first equation and a negative 3y in the second. Notice that the coefficients of y are opposites. This is perfect for elimination. If we add the two equations together, the y terms will cancel out. Let's see how that works. We'll write the equations one above the other and draw a line, just like in addition. We'll add the left sides and the right sides separately. On the left side, 2x plus 2x is 4a, and 3y plus negative 3y is 0. The y variable is eliminated. On the right side, 11 plus 5 is 16. This leaves us with a much simpler equation, 4x equals 16. Now we can solve for x by dividing both sides by 4. This gives us x equals 4. We've found the x-coordinate of our solution. But a solution to a system of two equations is a point, so we need both x and y. To find we can substitute the value we found for x, which is 4, into either of the original equations. Let's use the first one. The first equation is 2x plus 3y equals 11. We'll replace x with 4. This simplifies to 8 plus 3 equals 11. Now we solve for y. Subtract 8 from both sides to get 3y equals 3. Then divide by 3 to find that y equals 1. So our solution is the point 4, 1. This means that if you plug x4 and y1 into both original equations, they will both be true. Let's quickly check our answer. In the first equation, 2 times 4 plus 3 times 1 is 8 plus 3, which is 11. That works. In the second equation, 2 times 4 minus 3 times 1 is 8 minus 3, which is 5. That also works. Our solution is correct. In our last example, the coefficients were opposites, so we added the equations. What if the coefficients are the same? Let's look at this system. 5x plus 2y equals 16, and 5x minus 3 equals 1. This time, the x terms have the same coefficient, 5. If we add the equations, we'd get 10x, which doesn't eliminate anything. When the coefficients are the same, we need to subtract one equation from the other to eliminate the variable. Let's subtract the second equation from the first. Be very careful with the signs when you subtract. We'll write it out. We have 5x minus 5x, which is 0. The x variable is eliminated. Next, we have 2y minus negative 3y. Subtracting a negative is the same as adding a positive, so this becomes 2y plus 3y, which is 5y. On the right side, 16 minus 1 is 15. This simplifies to 5y equals 15. Dividing both sides by 5, we find that y equals 3. Now we have our y value. Let's substitute y equals 3 into one of the original equations to find x. I'll use the first one again. The equation is 5x plus 2y equals 16. Substituting y equals 3 gives us 5x plus 2 times 3 equals 16. This is 5x plus 6 equals 16. Subtract 6 from both sides to get 5x equals 10. Then divide by 5 to find that x equals 2. So the solution to this system is the point 2, 3. Let's quickly check. 5 times 2 plus 2 times 3 is 10 plus 6, which is 16. Correct. 5 times 2 minus 3 times 3 is 10 minus 9, which is 1. Correct. Our solution is verified. So far, we've seen examples where the coefficients were either the same or opposites. But what if they're not? Consider this system. 2x plus 3y equals 13, and 5x minus 2y equals 4. If we add or subtract these equations as they are, neither the x nor the y variable will be eliminated. We need to do some work first. The strategy here is to multiply one or both equations by a number so that one of the variables ends up with coefficients that are either the same or opposites. Let's decide to eliminate the y variable. The coefficients are 3 and 2. The least common multiple of 3 and 2 is 6. So we want to turn these into 6y and 6i. To get 6y in the first equation, we need to multiply the entire equation by 2. To get 6v in the second equation, we need to multiply the entire equation by 3. Remember, you must multiply every single term in the equation to keep it balanced. Now we have a new system of equations that is equivalent to the original one, but much easier to solve. Our new system is 4x plus 6y equals 26, and 15x minus 6y equals 12. Notice that the y coefficients are now opposites. Since the coefficients are opposites, we will add the two equations together. Adding them gives us 19x plus y equals 38. The y variable is eliminated. This simplifies to 19x equals 38. Dividing both sides by 19, we find that x equals 2. Now we substitute x equals 2 back into one of the original equations. Let's use the first one. 2 times 2 plus 3i equals 13. This is 4 plus 3 equals 13. Subtract 4 from both sides to get 3 equals 9. Then divide by 3 to find that y equals 3. The solution to this system is the point 2, 3. Let's check. 2 times 2 plus 3 times 3 is 4 plus 9, which is 13, correct? 5 times 2 minus 2 times 3 is 10 minus 6, which is 4, correct? The solution is verified. Let's recap the steps for the elimination method. First, align the equations so that the x terms, y terms, and constants are in columns. Second, decide which variable you want to eliminate. Look for coefficients that are already the same or opposites, or that have a small least common multiple. Third, multiply one or both equations by a number to create coefficients that are either the same or opposites for your chosen variable. Fourth, add the equations if the coefficients are opposites, or subtract them if the coefficients are the same. This will eliminate one variable. Fifth, solve the resulting single variable equation for the remaining variable. Sixth, substitute the value you just found back into one of the original equations to solve for the other variable. And finally, always check your solution by plugging both values into both original equations to make sure they work. You have now learned how to solve a system of two linear equations using the elimination method. This is a very efficient and reliable method, especially when the equations are in standard form. Great job!